Good morning, guys, and welcome back to another note session. Today is April 1st, and we're going to be learning about 8.6, or 9.6, which is secants, tangents, and angle measures. Okay, secants, tangents, and angle measures. We know what a tangent is, but we don't yet know what a secant is. So I'm going to write a definition of a secant, or a secant line, as I like to say. My yellow highlighter out here. Secant line. That is a line that intersects a circle in exactly 2 points now, instead of just 1 point like a tangent line. So, like, for example, here's our line, or our circle. A tangent, or a secant line, a secant line would be just something like this. Just a line that cuts straight through. The two intersecting points are right here and right there in green. So it's just a line that intersects the circle in 2 places instead of 1. We have 3 rules today. So rule number 1. If two secant lines or chords intersect inside a circle, then the measure of the angle formed is half the sum of the intercepted vertical, oh my gosh, I cannot spell, vertical arcs. And I'm going to show you what that means. So, say we have a circle here, and we have just 2 secants crossing. One here, one going this way. Okay, and let's name those. Let's go with A, B here, C, and then D here. And let's call this angle 1. Let's call this angle 2. Let me do those in different colors. We'll have angle 1 and angle 2. Alright, so what this is saying is the angle, here it says the angle formed, so we'll say angle 1, then it says is, which means equals. Angle 1 is half of the sum, which means addition, of the intercepted vertical arcs. So here is one of those, and vertical means straight across, so here's the other one. So half of AB plus CD. Okay, angle 1 is half of AB, the arc, plus arc CD. In the same way, you can say angle 2 is half of, and I'll use the orange color, BC plus AD. Okay, and it doesn't really matter what order those are in inside of these parentheses. You can put whichever one first that you like. So we have a couple examples. Let's go to example 1. Here's our circle. And we have some lines. Okay, we have X, we have 88 degrees, and we have 76 degrees. So to find X, easy peasy, all we do is we say half of 88 plus 76, and that equals 82 degrees if you put it in your calculator. Boom, easy. Next example 2. Moving right along. Another circle. 2 more lines. Remember, these are chords, which means a line that goes through the circle but not through the center. Okay, here we have 60 degrees is the angle. This arc is X, and this arc is 25. Not drawn to scale, obviously. Okay, so this time we say the angle, 60, is equal to half one arc, X, plus the other arc, 25. So let's try to solve for X. Let's get everything to the other side. First, I'm going to multiply by 2 to get rid of that 1/2. So those are gone. 2 times 60 is 120. And I'm just left with X plus 25. Subtract that 25. You get X equals 95. You can always double check if you want and say, plug it back in, say 60 equals half of whatever. But we don't have to do that this time. We're going to do one more example. This one's a little bit trickier, and then we'll move on to rule number 2. This is example 3. Okay, there's our circle. And again, we have 2 lines. I'm going to use my arrow lines this time. Ooh, okay. And here's our X. But this time, the arcs are the opposite arcs, 96 and 62. Okay, so I want you to think about how we might do this. Okay, how might we do this? I'll give you a hint. Let's look at this angle. And since this is a straight line, it's 180 degrees. So if we find this angle using the arcs we were given, we can subtract from 180 to get X. So that is what we're going to do. We're going to say, let's just call it Y. We can call it anything we want. We'll say Y is half of 62 plus 96. And Y would be 79. So now if we do 180 minus 79, that should give us X. 180 minus 79 is 101 degrees. That is our last example for rule number 1. Now we're going to move on to rule number 2. And I think this one's even easier. Rule 2. You have some writing to do. If a secant and a tangent intersect at the point of tangency then the measure of the angle formed I'm going to just say angle there, of the angle formed is half the intercepted arc. You guys are going to say, we've already done this before. Let me read this back to you. If a secant, which means intersects at 2 points, and a tangent, which intersects at 1 point, intersect at the point of tangency, then the measure of the angle formed is half the intercepted arc. This is more complicated. It sounds more complicated than it actually is. It's not that bad at all, promise. Okay, so first we have a tangent, or a secant line. We have a secant line first. We'll say it goes like this. We'll say it goes like that. And then another one that goes, or a tangent line that crosses like this. This is what our tangent lines look like. It says if they intersect at the point of tangency. The point of tangency would be right here. Then it says the intercepted, what does it say? The measure of the angle formed is half the intercepted arc. So let's say we have B up here and A down here at the point of tangency. We'll call this angle 2 and this angle 1. Ugh, I always do that, but let's put them in different colors. We'll say blue and orange again. 1 and 2. Okay, what it's saying is the measure of angle 1 is half of the arc that it intercepts. And the arc that it intercepts is right here, BA. So it's half, you can say BA or AB. And again, like I said, you guys are going to say, we've already done this before. We have. It's called a inscribed angle. Remember when we did that? Inscribed angle. It's kind of the same thing. Then the measure of angle 2 would be, oh, this is a major arc. So we need to have one more point here. Remember when I said a major arc always has 3 letters? Okay, so let's say it's half of ACB. Okay, A to C to B. We have just one example with this because this is pretty easy. So we have example 4, I think. Yeah. Draw your circle. Just going to freehand my lines here. We have our tangent line and our secant line. Okay, A is up here. D is right there at the point of tangency. C is down here. And B is over here. All right, this angle right here is 108 degrees. And it's asking us to find the measure of BCD. So I'm going to take my green BCD. Okay, that is the major arc here. Okay, so what will we do? Well, we can say we can find this arc first and then subtract 360. So let's say 108, the angle equals half of BD, right? The angle equals half of BD. So if we multiply by 2 on both sides, get rid of that half, BD would equal 216. So if this, let me write this, 216, then let's say 360 minus 216. That is 144. So my final answer, BCD, is 144. All right, and we have one more rule, rule number 3. Okay, this one says if 3 things. If 2 secants, 1 secant, and a tangent, or, in parentheses, two tangents, intersect outside of a circle, then the angle formed is half of the difference this time. Last time we did sum, this time we do difference of the intercepted arcs. This is almost just like the first rule, except I'll explain the difference in just a second. Okay, I'll explain it to you. We have three kind of drawings. So 3 different circles of 3 different cases, but it's going to be the same formula for all 3. It could just look 3 different ways. Okay. So our first case here was 2 secants. Oh my goodness, I did not mean to make that blue, but oh well. Okay, our first case is 2 secants. Well, I'll just make this one 2 secants. Okay, we have a point here. Say we have a secant line here and a secant line here. So this is with 2 secants. The next option is 1 secant and 1 tangent. So this time we'll have 1 secant line going like this and 1 tangent line. Barely touching. That was horrible, but oh well. Try again. That's better. So 1 secant and 1 tangent. 1 secant and 1 tangent. I abbreviated there. And our last option was 2 tangents. So I need to scoot over a little bit. We have a tangent. Oh my word, my drawings are horrible. We have a tangent there and then a tangent there. So that's 2 tangents. Remember, the difference between secant and tangent is a secant line goes through twice and a tangent line just touches 1 time. So if we have any of these cases, all 3 have the same formula. It is the angle equals half of big arc minus little arc. Okay, big arc minus little arc. I'm going to highlight the big arc in yellow. So here the big arc in the first example would be right here. All right, this one's bigger. This one's bigger. This one's bigger. And then the little arcs I'll highlight in light pink. This would be the smaller arc. Smaller, smaller. Okay? So it's always big arc minus little arc. I said I would tell you the difference. The difference between this and rule number 1. Okay, let's look at rule number 1 again. This is, you can highlight or underline or whatever. This is if the intersections are inside. See how it intersects inside right here? Okay, that is when you use addition. Down here with rule number 3, if they intersect outside, that is when you subtract. So that's the difference between rule number 1 and rule number 3. I have 2 examples with rule number 3, and then we'll be finished. Oh. Okay, this is example, I believe, 5. Example 5. We have a circle. This time we're going to have 2 tangents. So 1 here. Oh my goodness. You can definitely tell which one is mine. Which one was drawn on there. Alright, so we have a point here. 2 points of tangency. X and Z. And then this point right here in the middle is Y. This angle is 40. And this arc is 140. it wants us to find the measure of arc X, Y, Z. So this blue one right here, X, Y, Z. So our formula, oh, well, actually, we can do it in an even easier way. You can use the formula if you want. Okay, I'll show you the formula way first, and then I'll show you the easier way. The formula would be 40 equals half of big arc X, we'll just say, minus little arc 140. So we multiply by 2, get rid of that. This would be 80 equals X minus 140. Add 140 and 220 is X. However, you can do it this way, but there's an even easier way. This is an entire circle, right? Which is 360. We know 140 is one arc, so the other arc is just 220. That's the easy way, but you can do it both ways, however you want. And we have one last example, example 6. We have a circle again. This time we're going to do 2 secant lines. So I have one secant line that goes like this, the other secant line that goes like that. This point is A and B. The point all the way back here is E. And then we got C here, and we got D right there. Our angle, I'm going to draw an arrow because I don't have room, is 62 degrees. The small arc is X, the big arc is 141. Okay, this time we can't just subtract from 360, we have to use our rule. So our rule says that 62, the angle is half big arc, 141, minus little arc, X. Again, multiply by 2. Get rid of that half. It's gone. 2 times 62 is 124. We just have 141 minus X. If we subtract 141, we have negative 17 equals negative X. Okay, divide by 1 on both sides, and X equals positive 17. Alrighty, so there is the end of our notes. We looked at 3 different rules having to do with secant lines and tangent lines. So you can always do optional practice with this if you want, but I have already posted some practice for tomorrow in the Thursday folder, and it's just 2 skills practice. So take a look at that tomorrow or today, whatever you want.